Hello student, in this module we are going to illustrate the applications of R on survival analysis. Basically the Kaplan Meier estimations procedure we will illustrate in this module. Kaplan Meier estimations procedure is a non-parametric approach. It is also known as the distributions free approach. As earlier presentation we have seen, the distributions of time is the important variable in survival analysis, and how the time distributed in survival analysis it's not required to consider when we are applying the Kaplan Meier estimation procedure. Two important variables are very important in Kaplan Meier estimations. One is the duration of time that we mentioned, and another one is the date or event of interest. In medical research, event of interest may be death or relapse. When we are trying to find the efficacy of a new drug in comparison to existing drug, and response is survival duration, then we follow the Kaplan Meier estimations procedure. We take the Kaplan Meier estimates for both the treatment groups and compare treatment groups on survival durations. If we found that survival durations are quite different in both arms, then we can conclude that one term is doing better than in comparison to another arm. And arms are basically the treatment arm of new drug, and another arm basically the treatment arm for existing drug. In survival analysis, Kaplan Meier estimations basically used to estimate the durations in both arms. Once we get the estimation of duration for both arms, then we can compare those both arms. So, in this module we will see how to plot the survival distributions curves from sample data. After that, we will check how to get hazard rate estimations using R on the same data set. And last but not least, we will check the survival curves difference, how to make inference on that. So, basically the objectives of this module is to plot the survival curves, get the distributions of hazard functions, and compare the survival curves using R. Here we are going to see Kaplan Meier estimation using R. In this end of this module, we will see the Kaplan Meier curves using R, how to plot Kaplan Meier curves. We will see how to get cumulative hazard curves using R, and estimation of survival curve difference, and we will get the statistical inference on that. This survival example data is considered from paper of metronomic chemotherapeutic trial data published by Patil et al. In 2005. This is a partial data set from that paper, where arms are denoted as 0 for cetuximab arm and 1 as methotrexate arm. So, these patients were head and neck cancer patients, and durations of their survival are considered here for survival analysis. Here times is survival times or censored times considered here. Third variable is status, where these patients censored or not denoted by this variable. If those patients censored, these were denoted as 1, otherwise denoted as 0. it should be keep it in mind that when we are dealing with survival analysis, sometimes we consider the variable called death or delta, where we do consider status of the patient if they alive as 0 and if they died as 1. But here the same variable is represented by status, but where status is denoted if the patient censored as 1 and if the patient died as 0. So it need to keep it in mind for considering the variable. What is the coding of the variable is dead or alive or censored or not censored. Generally most of the packages compatible in R are considered the variable called status, and in your study if your variable coded as death, then you have to alter it in status to perform the survival analysis. Now fourth variable, here we consider sex, and again male and females coded accordingly. Now here we will illustrate our objectives through these questions to find out the treatment effect difference on survival of the patient. Now we are going for importing the data. Now first variable arm 0 and 1, 0 stand for cetuximab arm and 1 stand for methotrexate arm. Second variable time, that is for first individual it observed for 63 days, second individual 68 days, and like that. Third variable status again given as 1 or 2. Here we are putting 2 and somewhere you may find it has given as 0 also. So it's depend, but to avoid that confusion, here we have put it that 2 for not censored patient. Now again 1 is given for male and 2 given for female. Now the whole variable arm, time, status and sex assigned through a data.frame functions and given to a database called chemo. Now we are coming to for R coding to get the Kaplan Meier curve. Here we had given the data that is called chemo, here assigned last function, last end of this function, that data equals to chemo, and before that we have used two functions, that is surfit and surf. These functions are available in the library called survival, and in that library if we put these variable time and status follows to arm, so it will give the estimate of survival curves between two arms, that is cetuximab and methotrexate arm. What is the status corresponding to their duration of time? Basically it's a comparison of survival duration between two curves through their survival duration estimates. Now whole function, whole estimates assigned to chemo.surf as a, now if we put into the plot function the chemo.surf, we will get the survival estimate. In next slide we will see how the plots are coming for comparative curve between cetuximab and methotrexate arm. Now to into the graph to show the to represent the cetuximab and methotrexate arm, we can use the function called legend, and what will be the x-axis wise positions of the legend, that is denoted first, and y-axis wise position will be denoted later. Here we can see that x-axis wise positions is given as 50, that is this legend will come at towards the 50 days, and y-axis wise is given as 0.2. so probability of survival that is given through y-axis, so 0.2 place it will start to give the legend values into the same graph where we will get the survival plot. Now put the title of the curves, we will give the function called title, and into that we will put Kaplan Meier curves for metronomic study. So as like your own study, whatever will be your study title, you may put into the title function and after that into the inverted comma. Now in next slide I will see how these functions give us the result. Now see the R output, it gives the title, it gives the Kaplan Meier curves for metronomic study. Now as we have mentioned the legend, through legend it is giving us the legend started from 50 of y axis and end up with 0.2 in y axis for cetuximum and methotrexate. Now comes to the main graph. It gives two curves, one for cetuximum, another for methotrexate. See, maximum duration of patient followed in the cetuximum arm is not more than 200 days, and for methotrexate arm it was more than 250 days. If you go into the raw data, you can see that maximum duration in was 193 for cetuximum arm and 257 for methotrexate arm. Here if you check the maximum of time, you will get 257 and corresponding treatment was given as methotrexate and 197 as cetuximum patient. Now come to the graphs again. Now the cross marks give the censored observation obtained in this data set. See, in both curves started from survival with probability 1 as given with y axis, and after certain time, that is around 50 plus days, around 60 days, the cetuximum arm suddenly jump to probability around 0.9 and thereafter again it followed for 250 days, whereas the first term, that is cetuximum arm, were dropped around 120 days and thereafter it followed and stopped at nearly 200 days, that is 193 days. So here we can see that both arms cross to each other one time, that is around 120 days. So based on that we can go for further analysis that the Kaplan Meier distributions curves are different or not. This is the real situation where it is very difficult to state that which arm is doing better, because the distributions of both curves cross to each other at certain point of time. In details we are not going here to handle such kind of problem. Now we are going for to get the survivals estimates and cumulative hazard curves. So here initially we assign LS sub 2, L sub 2 with subfit and sub functions for our chemo data. To get the cumulative hazard curves, we will put plot of that L sub 2 with LTY. That LTY will give us the type of plot, that is will be broad or narrow. Plot figure will give by LTY function. and as a function if we put as cum has, it will give us that cumulative hazard functions. As X lab we are given days and Y lab we are plotting cumulative hazard. It should be noted that in earlier plot we didn't put that leveling for X lab and Y lab, but here we are putting X lab and Y lab. Now legend again are like earlier graph we had given 50.2, here we are giving 50.8 for cetuximab and methotrexate, and title of the curves given as cumulative hazard curve for metronomic study. Now see the plot as our output. This is the cumulative hazard curves for metronomic study, where hazard rate started from 0 for both the arm. As days keep on increasing, cumulative hazard keep on increasing for both the arm. The maximum observation observed for cetuximab arm is after nearly 200 days, whereas maximum observations obtained for methotrexate arm is 250 days. It is to be noted that high hazard rate observed for cetuximab arm in comparison to methotrexate arm. So graphically we can understand the difference between cetuximab and methotrexate arm, but based on this graph it is very difficult to state how this difference is exist. Is it real significant difference or not significant difference? To get that idea, we have to go for survival curve difference estimate. That can be done by Lagrange test or mental Hensel test, that will come for next modules. Now here we will see the Kaplan Meier curves, that is again these two functions, that is serve fit and serve coming into the library called survival. Here time of the patients that followed given first and status of the patient that followed given later. After that field 1 is given. The earlier version of library survival used to follow this trial 1. Now recent version you may put trial type also to get the type of survival difference, and after that we are putting as we are assigning times equals to into the inverted comma Kaplan Meier for conf type is as log and data equals to kmo. So whole thing is assigned as km0, and later on we will call the km0 to get the estimate of survival curves as Kaplan Meier production. Now as a summary function we are calling into the summary function we are calling the km0 for times 10 to 20. So for time interval 10 and 20 we will get the Kaplan Meier estimate. Now see the R output. This is the R output snapshot taken from R result, where we had given the function that we have used, that is survive fit, and thereafter time and status, and as a data we had given the kmo, that is our data set name, and as a result you may see as from 4th row line onwards we are getting time, number of people were at risk at that time given as n dot risk, number of people event occur given as n dot event, and probability of survival given at survival, standard error and 95% confidence interval lower and upper also given. See since no event occurred till 10 days, so all patients were at risk. Again one patient censored between 10 to 20 months, that is why number of event again showing as 0, and number of patient at risk showing by second column is given as 26. You can see that for first row number of patient at risk showing at 27, but number of events showing as 0, whereas from 10 to 20 days, number of patient at risk showing as 26, whereas number of events showing as 0, because one patient during that period not died the sensor. So since no survival changes over this period, so we are getting as lower confidence interval, 95% confidence interval as 1, and upper 95% confidence interval 1, as also survival probability as 1. This is the Kaplan Meier estimates. Now going to next code. Now we change our time point from 10 to 20 to 20 to 50 days. Now see the result. Now again, no observations obtained that were found. The same results are given here. Now we are trying to find out Kaplan Meier estimates with confidence interval. In the function plot, we are calling Km0, and as a mean we are giving the title as Kaplan Meier estimate, a hat of h, hat of s of t with confidence interval, and as a x lab we are putting time t, and y lab we are putting survival. Let's see the Kaplan Meier outputs. It gives 3 lines, one a broad line given the exact point estimate of survival curves. Here no strata, no arm is considered. For all observations, Kaplan Meier estimates is given. If you see, the upper line is giving the upper confidence interval of survival plot, the dashed line, and again lower dashed line is giving the lower confidence interval of survival estimates. Here we can see somewhere these dashed line also given on the broad line, broad black line, that is shows the censored observations. So here total observations obtained for till time point of 250 plus days, and here you can see through y axis survival probability was 1, and when time keep on increasing, duration probability of survival keep on decreasing. At end of 250 days we can see survival probability was around 40%, that shows as y lab as 0.4. Now coming to the find out the survival difference. To get the survival difference into the library called survival, we can use the function called survdiff, colored in yellow color, and again we put capital S URV function into time and status for between the arm for the data came. That this function will give what is the treatment wise survival difference. If we put the result, if we call survdiff, then we will get that for arm 0, that is cetuximab, 12 patients were observed, and arm 1, that is methotrexate, 15 patients were observed. The observed difference, expected difference is given here, and later on the p value also given as 0.774. It shows that there is not any significant difference on survival duration between both the arms, where chi-square test value observed with 0.1 and with 1 degree of freedom. It shows that both arms doing same in terms of survival. However, graphically it shows that there is a difference in terms of survival. Now here we will see how strata wise survival difference can be observed. Earlier slide we have seen survival duration with SURF function, and as a covariate we had considered arm, that is cetuximab or methotrexate. But here we are considering another variable, that is sex, and between both male and female what is the difference that will obtain by putting strata and within parenthesis variable name with sex for database data equals to kim. Again we will see the R output. R output will be like here. Again it shows, however p value reduce more 0.47 0.77 to 0.45, but here again no difference observed between the arms on this data, that is male and female. The chi-square test value giving 0.6 with 1 degree of freedom. So again we can say, however there was no treatment difference on survival between both arms. Again we have considered 6 strata to consider male and female and found that no significant difference observed. Consider with 95%, no significant difference observed between the arms. This is the whole thing on survival analysis to get the Kaplan Meier estimate, to get the survival difference curve. In this module we have seen the statistical package and tools in R for Kaplan Meier estimator. We have seen how to read the survival data into R, how to graphically represent the survival data using R. The statistical inference from the sample data set has been illustrated. In other sample data, the same kind of statistical inference can be obtained based on the research hypothesis. Here we have generated the hazard rate estimation from survival data, and we have compared the two survival curves. Graphically, survival curves can be compared and statistical inference to comparing the survival curves also illustrated. The in-depth analysis for survival analysis further can be carried based on preliminary application of Kaplan Meier estimations. Since it is a non-parametric approach, we do not need to check the distributions. Once we found that there is a difference present in survival analysis through the curves, then other factors or covariates of interest can be considered for in-depth analysis, that we will check our next modules on Cox proportional hazard modeling.